Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Dynamic Nebula by GDC. And here are the rules. Normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 without repeats in any row, column, or box. We also have fog covers the grid. Here's an examples. Interesting. Placing a logically deduced digit in a cell lifts fog from that cell and possibly other cells. So if we place the correct digit here, it will clear the fog around that cell and possibly other cells in the puzzle. So this is dynamic fog, which is probably why it's called dynamic nebula. We also have spiral galaxies, where we divide the 9 by 9 grid into orthogonally connected and 180-degree rotationally symmetric galaxies, such that each cell is part of exactly one galaxy. We also have squares, where digits don't repeat in a galaxy and sum to the value on its central square clue. So anytime a square is in a cell, that's a central cell of a galaxy. And all centers are marked. So all the centers of galaxies are marked by a square. And if it has a digit, actually, I think the number on its, I think every square will have a number on it. And so the digits in a galaxy sum to the value in the central square clue. So for this galaxy, the sum of all the digits must sum up to 39. That's interesting. Circle digits count the number of cells in their galaxy. So the square is the center of a galaxy, and the galaxy must be orthogonally connected, which just means that if you go from any square in the galaxy, you must be able to trace a direct line from the center, from any square in that galaxy to any other square using edges. So for example, for this one, we're going to make this one, essentially, we're going to choose that as a galaxy. So say we could not have something like this. The galaxies have to be 180-degree rotationally symmetric, which means essentially if you rotate the shape 180 degrees, it will look exactly the same. So this is an example of a rotationally symmetric galaxy, but it's not orthogonally connected, because if you try to go from here to here, it cannot work, because you should be able to go from edge to edge through edges from any shape of the galaxy from any square in the galaxy. You should be able to connect to any other cell just by going through edges, and this would not work, right? Because you can't go through edges through every cell in the from one cell in the galaxy to the rest, right? This would work. Okay, I'm not doing a very good job of explaining this. But whenever you have a region that's orthogonally connected to you must pass through every section of. If you try to connect from any cell in the region to another cell in the region, you should not have to get outside the region by connecting through edges. I think that's the best way of putting it. I don't know. Maybe there's another way of putting it that makes it easier. But basically, the long and short of it is you can't have a galaxy like this or a region like this, because you can't go through just edges in this galaxy and may be in the same region, right? If you try to connect here to here, the problem is if you try to go through edges, you'll get outside that region. So an orthogonally connected region
has to stay inside the region from any square in that region to any other square in that region. And it must be going through edges. So this is an orthogonally connected region because if you try to go from here to here, you can always go through another cell in the region and go edge to edge, right? So you can go edge through that edge, through that edge, through that edge, through that edge, through that edge to reach this cell. This is not 180-degree rotationally symmetric, though, because if you rotated this region 180 degrees, this would not look the same as the region, right? So galaxies must be rotationally symmetric around their center. And this is the center because the squares are the center. Anyways, I hope that was clear about orthogonally connected regions. I wish there was a pithier way of explaining it. Maybe there, I mean, there probably is, actually. I'm just not thinking of it right now. But those are all the rules. If you like to play along, there's going to be a link in the description. Okay, and again, the circle digit in the numbered cells counts the number of cells in their galaxies. So if, say, this were, well, ignore that there's no, well, okay, let's just make this symmetric. If this is the galaxy that this circle is in, it would have to be a 7, right? Because there are 7 cells in that galaxy. And that's how circle digits work. Those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, this is a region. This is a separate region. So this cannot go this way. It can only go up here. And this is a center of a region. Well, how many digits have to be in this region? It can be, you can't have 9 because 9 digits would add up to 45. You can't have 5 or less because 5 or less would add up to at most 35. So it must be at least 6. This is obviously a boundary. So since this is a boundary, this has to be a boundary. Actually, let's make it red so that we have clarity here. This is red, this is a boundary, this is a boundary. Therefore, to go symmetric, to expand this galaxy, it must go up and down. Now, this is a hard boundary here, up here. Since this goes up and it goes down, this must be a boundary because these are separate galaxies. Therefore, this must be a corresponding boundary. Where can it go? Again, this is a boundary because of this boundary here, right? If you try to go further here, and this is part of this galaxy, it's not 180-degree rotationally symmetric now, right? Because this is no longer valid. So it must go here. This is part of it, and it can't be 6, so it must include another digit. So this is part of the pink galaxy. This is the part of the pink galaxy. If we tried to include another digit here to be rotationally symmetric, it would have to go here, and that would be 9 digits, so that doesn't work. We know this is 7 in size then for this galaxy. So this is a 7. And it has to be this way. Well, this galaxy is limited here. So because it has to be, it cannot extend any further out this way. It adds up to 14. We know this is 7 unique digits. Oh, it doesn't actually, we don't know that. There's no restriction on the digits inside the galaxy. Oh, no, it says digits don't repeat in a galaxy. Okay, that is, okay, so that's guaranteed. Okay. And sum to the value, so yeah, it's typical killer cage clues. 7
cannot add up with another digit to add up to 14 because it would be 7 and 7, and you can't have repeats in galaxies. So 7 cannot be in this pink, the rest of this pink space. Can't be here or here. Can't be here because of this 7. Where's the 7 in box 3? It must be here. So this is 7. These two digits are either 5, 9, or 6, 8. Well, whatever this digit is must see the rest of this galaxy, right? And this galaxy must contain 7 digits, which add up to 39. That means the other 2 digits, which are not in the galaxy, must add up to 45 minus 39, which is 6. So the other digits in the galaxy must be either 1, 5 or 2, 4. Well, whatever digit this is, it's 5, 6, 8, or 9. That means that digit has to be here, but this digit sees all of these digits. So this digit, whatever it is, cannot be in this 39 galaxy. Well, we already said that 1, 5 or 2, 4 cannot be in this galaxy. This digit, if it were 6 or 8, would have to be in this galaxy, so that would eliminate all possibilities for this galaxy. If it were 9, it could not be in this galaxy. Sorry, it would eliminate 9s in this galaxy, which we know there has to be a 9 in this galaxy. So this galaxy has a 9, it has to have a 6 and an 8, therefore this must be 5 and this must be 9. Which forces this to be a 9. This has to be 2, 4, 6, 8, and 3. Because that's the only digits remaining that add up to 39. This must be a 1. This is a galaxy that adds up to 4. It must be 1 and 3. So this is a galaxy in itself. Okay, let's draw borders here. Borders all around the rest of... So this is part of a galaxy. And we don't know where it goes. This is a galaxy by itself. Make that green, I guess. This is a separate galaxy. It adds up to 21, which means it's at most 6 digits. And it's, no, but it can't be 6. It's the center of a galaxy. So it's at most 5 digits. It cannot be 1 digit. It could be 3 potentially. But if it were 3, I guess it could be 4, 8, and 9. So say we had this galaxy be 3. The problem is, if it's 3 in size, it's either this way, these 3, or these 3. The problem is, either way, it cannot contain a 7, and it cannot contain a 9. So at most, it would be the digits 5, 6, and 8. And 5, 6, and 8 adds up to 19 at most. Therefore, this galaxy must be 5 cells. Okay. So this galaxy must be exactly 5 cells. What does this galaxy look like, right? If we assumed that these were not part of the galaxy, this could only be 3 in size because it cannot go, well, yeah. If we try to go here and these were not part of that galaxy, it cannot go here. It cannot extend here because it's blocked by there. Can't go here, so this is out. Can't go here, therefore, because of this cell. We're obviously excluding these. It would have to go here, but then this would be 5 in size, and we already have a 5 there. Therefore, no matter what, this galaxy must go this way. We know that for certain. It could extend here. It cannot extend to here, actually. So we know the boundary has to be here. Therefore, because it cannot be part of that. because this is not, and this is no longer a boundary. Sorry, this is a boundary here, so this is a boundary here. So it either goes 5 here, or it goes 5 here. Well, if it goes 5 this way, this 3 cell can never be 180-degree rotationally symmetric. So it cannot go this way. It has to go this way. So this is a galaxy in itself. It adds up to 21 without a 7 or a 9. This is a 1-3 pair here. Add up to 4. This is 21. This is 16. 21 plus 16 is 37. So these two digits must add up to 45 minus 37, which is 8. So it cannot be 1, 7. It has to be 3 and 5. Wait, that doesn't work. Hold up. Okay, that's not right. Twenty-one plus 16 is 37. Huh. That's a little problematic. Okay, so was my logic wrong? Okay. We try without these two, right? But this doesn't work, right? Because this is not 180 degrees symmetric. It does have to be this way, right? It can't be 5 here. It has to be an odd amount for this galaxy. We know that for certain. It can't be 6 then. Can't be 3 because we have 5, 6, 8 if it goes this way, 5, 6, 8 if it goes that way. But if it's 5 this way, that's 21. 9 is 630. 7. 45 minus 37 is 8. And this would have to be, it cannot be 1, 7, but it can't be 3, 5 either. So that can't be the case then. This has to be 1 and 3. We know that for certain. That's a 1, 3. The rest of this is 2, 3, 4, 6, 8. Right? This cannot go this way. Because then that would be 21. It can't be greater than 6 because the lowest... If we had 7 digits, that adds up to 28, right? 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 is 28. Huh. That's weird. Okay, so this has to be a 7-9 pair here. This has to be 2, 3, 4, 6, 8. Oh, this can't be 3 here. This can't be 3. This has to be 2, 4, 5, 6, 8 here. This is confusing here. It can't be all 5, but you can't have a cross because this is not 180 degrees symmetric then. But we can't go this way because that's not 180 degrees symmetric. If we try to go that way, this would be 5, which is not allowed. So what else can it be then? Why am I running into a problem already? This can't be 2 because if it were 2, the square would have to be either here, 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 or here on the boundary, and it's not. This one's really blowing my mind. I don't understand how this can work. Can't be 5, 6, 8. This is at maximum 5, 6, 8. This is at maximum 5, 6, 8. This has to be 5 and 9. This has to be 1. This has to be 7 because there's no other place for it in box 3. This has to be 5 digits then. But this can't go that way. It can't go that way either because that would be 5. Can't go this way. Can't go this way because then this is not symmetrically rotation or 180-degree rotationally symmetric. What am I missing here? This has to be 7 here because this was a boundary. We got this all right. This is 9, this is 5, this is 9, this is 1, this is 7. That's all correct. We know that for certain. This is a 1-3 pair. How does... Okay, I don't know. My brain is not working very well right now. It can't be 7. That's the problem, right? So we were trying to think, can it... Oh! These could... It does have to be a square. These can all be singular galaxies here. That's the reason why. It cannot be 5 here again, because if this is 5, that means 21 plus 16, which means these two would have to add up to 8, but this cannot be 1, 7, it cannot be 3, 5 because of the 1, 5 here. Therefore, this must be a galaxy here. So this must be a galaxy. So this is a galaxy here. I guess it could be a 2 and a 1. We don't know how this is exactly broken up. This is 2, 3, 1, 5, 4, 6, 8. This adds up to 21 without a 7 or 9. What are the possibilities? From 1, 2, 3, 4, 6, and 8. That's 21 plus 8 is 29. So we have to subtract out 1 digit. No, 2 digits that add up to 8. Well, 1 has to be part of it. 1, 2, 3, 4, 5, 6, 8. So it's either 2, 6 are removed or 3, 5 are removed. We know 1 has to be one of these. Because 1 and 7 would have to be removed to remove 8 from 1 through 8. This cannot be 1. It cannot be 8. It cannot be 4. Because this must contain 1, 4, and 8, and either 2, 6, or 3, 5. So this is 2, 3, 5, or 6. One of these is 1. Can this ever be 8 here? Well, it would have to be part of this galaxy, right? To be part of 8. Because this is not symmetric in any way here. Yeah, this is the center of a galaxy. So I don't think this can ever be 8. It could be 6, and the only 6 it could be is part of this. I think this one has to be part of this galaxy, right? If it's not, where else could it be? Can't be this way. I guess it could be, it can't be 2 because this is not the center of a galaxy. 4, that doesn't work. With 4 without going here. This doesn't work. This doesn't work. Yeah, it just can't be 4 there. 6 doesn't work either. Without going here. Like, yeah, how How is this 180 degree symmetric? This has to be part of this galaxy here. So it's 4 or 6. It cannot be 8. Actually, it could be 8. No, but it adds up to 18. Therefore, it can't be 6 or 8. This is 4. There we go. This is a galaxy, so this has to be the size here. And it must be this. So this cannot be 4. This can't be 4. None of these can be 4. This can't be 4. We know then 4 has to be one of these 3, which means this can't be 4 here either. So that's up to 18. This is 2 digits that add up to 10. Well, the only 2 possible digits here can't be 1, 9, can't be 3, 7, can't be 4, 6 anymore because this requires a 4. So it has to be 2 and 8. So this is 2 and 8. That eliminates 2 and 8 from the rest of the box. So this can't be 2 and 8. This can't be 2 and 8. Where is the 8 in this 21 cage? And there has to be an 8 in there because we have 2 digits removed from 1, 2, 3, 5, 1, 2, 3, 4, 5, 6, 8, which adds up to 29 to add up to 21. So this has to be an 8 here, which means none of these are 8. We have a 2, 6, 2, 6 pair in box 1, which eliminates 2 and 6 from the rest of the box. Therefore, this is 5. This 2, 6 pair eliminates 6 from the rest of that box, so this from the rest of the row. So this is 3, which makes this not 2, 3, 6. It has to be 8. So none of these are 8. These can't be 2. This is a 3, 4, 6 triplet, which eliminates 3, 4, and 6 in the rest of the row and the rest of the box. This can't be 3, 4, 6, so this is 1. This is 3. This can't be 3 or 5, so this is 6. This must be a 2 then. This is a 1, 4 pair here. This can't be 1, 3, 4, or 6, so this must be a 5. This is not the center of a galaxy, so this galaxy is probably here, and then we probably have a galaxy there. I don't know if that gives us very much. This is another galaxy, so we're going to make it red. This has a boundary here and here, so it must expand here because 37 cannot be in just 2 digits. Can't be in 4 digits either. So we have a boundary go here and here. So it must go to at least, it must go at least here. So that's 6 digits. 6 digits minimum adds up to 39. So it could be 6 digits. And so it's 6 digits or it's 8 digits. We're not sure exactly which. This is a boundary. So this is 6 or 8. If it's 8, it cannot be 8. If it's 8 cells in there, that means we have 1 digit remaining out of 1 through 9, which must not be in this region. But 45 minus 37 is 8. So therefore, this must be 6 in size. Right? If we tried to have an 8 cell region, we only have 1 digit, which is not in the region, and it must be 8, but we already have an 8 in the region for 8 size. So this is 6. That means the other 2... We have 6 digits adding up to 37. The other 3 digits must add up to 8. So it's either 125 or 134. So either way, you need a 9, you need an 8. 8 has to be then here. There has to be a 9, there has to be a 7. These 3 digits add up to 14, and there's this 6 means this can't be 6. So this is 2, this is 6. This is greater than 0. But this cannot be, this has to be a region by itself. This is greater than 0. That's 6. So if we try to, I guess it could be this way, right? We know this is a part of a region, but we don't know where it goes to. So we have blue, it could go to here, or it could go to here. Yeah, sorry, it could just be these four. We don't know which. There's no one in this 6-cell region, though. We know that for certain. One can't be here, one can't be here. Where's the one in box 4? It must be here. So this adds up to 14 with a 1. It cannot be 168. No, sorry, it'd be 1. Cannot be 149 because we already have a 4 in the region. So it'd have to be 158 or 167, but 6 can't be in the region either. So it's 1, 5, and 8. Therefore, this must be 5, and this must be a 1, 8 pair here. 3 has to be in this region. So since there's a 3 here in this red region, red galaxy, since there's a 3 here, that's 3, 6, and then the rest must add up to 37 minus 9, which is 28. So that means it's 4, 7, 8, 9 here. This can't be 4 here, so this must be a 4 here and an 8. We have 7, 9. It cannot be 5, and it cannot be 1 or 2. So this has to be 2 and 4 here. 3 is one of these two. So 3, 4, 6, 7, 8, 9 adds up to 37. That's fine. So this can't be 7 here. 4 is one of these three. Therefore, 4 has to be one of these three in column 6. This is 2, 4, and it's 1 out of 7 or 9. We're not sure which. Six cannot be here. 6 cannot be here in box 5, where it can't be here either because it's in the same region. Therefore, where is the 6? It has to be here. Okay, so this is a galaxy. This is a boundary here. This is part of this galaxy here. And this has to be part of a galaxy, and we know there's no centers here. So it has to be part of at least this galaxy, which means this is size 6, right? I think that's... This edge means this is blocked. This blocked. This edge means this is blocked. And the rest of this is edged out. So this is size 6. This is 35 in size. We have 6 digits. 3 of them add up to 14. The other 3 add up to 21. Right? 35 minus 1, 6, and 7. That's 14, which is 21. So 3 digits adding up to 21. That must be... It has to be, I think, 4, 8, and 9. You could have 4, 8, 9, 5, 7, 9, or 6, 7, 8, and we already have a 6 and 7. So this has to be 4, 8, 9. 9 cannot be here. Where is the 9? It has to be here. This is a 4, 8 pair, which eliminates 4 and 8 in the rest of the column. This can't be 4 or 6, so this must be 3, which eliminates 3 here and 3 here. This can't be 9. This can't be 9. This is a galaxy in itself. I guess we'll make it blue. We don't know about this. We haven't cleared out any space there. Eight has to be one of these. 8 is one of these. 8 is one of these. So in box 4, 8 has to be in row 4 or 5. In box 5, 8 has to be in row 4 or 5. Therefore, the rest of box of rows 4 and 5 cannot contain an 8. Therefore, this can't be 8. This is 4. This is 8. Let me clear out right now the cells so we can make sure that the fog is cleared. Yep. That fog is cleared. 4 cannot be here. So one of this can't be 4 either. We know there's a 4 in this region to add up to 37. So 4 has to be here. This can't be 4. This must be a 4 here. If this were 9, it would see all the possible 9s in this region. So this cannot be 9. This is a 2-7 pair, which eliminates 2 and 7 from the rest of the box. So this can't be 7 here. This is a 3-9 pair, which eliminates 9 from the rest of the region. We already knew 3 wasn't there. Therefore, this can't be 9. This is a 7, which forces this to be 9. So this is a galaxy by itself. Make this pink, I guess. So this blue region ends here. Cannot be 2. It must be 7 because we already have a 2 in the region. So this is separate. This must be a 2 then. And it's its own region. So this will make... It has to go this way. 3 and 9. The rest of these digits are 5, 8, and 9. The rest of column 2 is 3, 4, and... Not 6. 3, 4, and 7. The rest of column 3 is 1, 2, and 6. This can't be 7 anymore. We have a 4, 8, 4, 8 pair in box 5, which eliminates 4 and 8 in the rest of the box, and the rest of the 4 and 8 in the rest of the row. So this is 1, this is 8. Let's just make sure that these colors worked. Yep. This can't be 8. This is a 7. 7 cannot be here. Whereas the 7 in box 6 can't be here because of these 7s. It must be here. So this is a 7. Interesting. It's in a 7 galaxy. So this is a separate galaxy here. Let's actually, I think well, I don't know. Is the coloring, I feel the coloring actually makes it harder to see. But maybe it's just me. No, actually, I think the coloring does make it easier to spot the galaxies. Anyways, okay. We're gonna make this blue, I guess, and this will be red. This must go down here. The remaining digits here in row 4 are 2 and 3, but this can't be 2 because of this 2, so this is 3, this is 2. This is the center of its own galaxy here. I guess we'll make all of the single cells... We should make all the single cells the same color. We're going to make this not red. So all the single cells will be red. This could be part of this galaxy here. We don't know. Remaining digits in row 5 have to be 1, 3, 5, and 9. But 3 and 9 cannot be here. Therefore, this is 3 or 9. We have 1, 5, and 1, 5. This can't be 1 because of that 1, so this must be 5, which makes this a 1. This is a center of its own galaxy. So this is red. This has to be 7, but it's not the center. That leaves this as a 2. So this is 2. These have to be 3, 9, 1, and... Okay, this 9 means this can't be 9. So this is 3, which makes this a 9, which makes that a 3. This is 29. The remaining digits here are 1, 5, and 9. But this can't be 9. This has to be greater than... It has to be at least 4 digits. But it has a 3. So 3 and 6... these are borders that have to be drawn. So it must go down here because 3 and 6 with 8 and 9 wouldn't add up to even 29. So it has to be these digits in the galaxy. You have a 9. What are the remaining digits? This 2 eliminates that from being a 2. So this is 8, this is 2. That leaves this as 1, 4, 5, and 7 as possibilities. So we have 2, 3, and 6, which adds up to 11. Is that right? 11? Yeah, 2, 3, and 6 adds up to 11, so the rest must add up to 18. Well, if it's 1 and 9, this is 8. 5 and 9 would have to be with 4. So we have a 4, 8, 4, 8 pair in column. Actually, and this can't be 5. We have a 4, 8, 4, 8 pair in column 4, which eliminates 4 and 8 from the rest of the column. Therefore, this is 1. Let's remove the orange. Oh, we already have cleared that out. So this is 4, which makes this 8, which makes that 4, which makes this 8. This must be 9 and 1, which makes that a 5. This is a separate galaxy because it's blocked by its own on these sides. So this is a separate region. This cannot be 5. This is a 1, 4, 7 triplet. This must go down here. So this is I'm going to make that yellow. We don't know where it goes though. This must go down here. Make that blue. Could this be part of the same? No, it can't be part of the same galaxy. This has 7 in it. So the center cannot be here because that would block this galaxy. So it cannot be here. It can't be here because if this were the center of a galaxy, it doesn't go anywhere. It can't go 7 down. So it has to go this way. So this is a galaxy here. This can't be 1 or 7 because they're in that galaxy. So this must be, this is a galaxy here. This must be a 4, which means this cannot be 4. The remaining digits here are 3, 5, and 9. The remaining digits here are 2 and 6. We have 3, 5, 9 here in this region, in this galaxy. This can't be 1, 4, 3, 5, 7, or 9. It can't be 2. It can't be 8. This must be a 6 then. This is 6. So this cannot be 6 here. This can't be 4. Remaining digits, this 6 eliminates that from being a 6. So this is 4, this is 6. I think that's cleared now. Yep. Remaining digits in column 7 are 5 and 9. Remaining digits in column 8 are 1, 2, 7. Remaining digits in column 9 are 3, 4, and 8. But this can't be 4, 8, therefore that forces this to be 3, which makes this a 7. This is a region with this as a center, and we know that this blocks off here because of the boundaries already there. These can't be 2, therefore it's a 1, 7 pair. This can't be 7 because of that 7, so this is a 1, which makes that a 7. This is its own region. This must be a 2. This 1 eliminates that 1, so this is a 2. This cannot be 8. This is, since it's already blocked off in other areas, this has to be a region into itself. So this is red. This has to be orange. So all of this is orange, which means this is a region. It cannot be 4, 7 here because of the 4, 7 in the region. So this is 3, this is 4. This 4 eliminate. This can't be 3 anymore. This can't be 4. This is 8. This is 4. This 2 eliminates that 2, so this is 6. This is 2. None of these can be 2. This can't be 6 either, so this is 1. This is 6. None of these can be 3. So where's the 3 in column 5? It has to be here, so this is 3. We have a 5, 9, 5, 9 pair in row 8, which eliminates 5 and 9 in the rest of the row, so this is 8. This can't be 8 here. This adds up to 13, and it's only size 2. So this, oops. I guess we'll mark this as green. So this is a region. This has to be a region in itself. So this is a red region by itself. This must be then 5, which makes this 9, which makes this 5, which makes that 9, which makes that 5, which makes that 9. This is a region by itself. This must be a region by itself, and, oops. This is a region by itself. So we'll color in the rest of the regions. I guess we'll make this green. This will be orange. This will be pink. So this 1 means this can't be 1. This is 7. This must be 1. And that's how you solve this. Yeah, apologies for this part. I forgot about that. Yeah, there's no restrictions on the number of galaxies you can have. So yeah, pretty cool. Once I've realized that this was an error here, assuming it had to be that way, that everything pretty much flowed from there. So anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.